Okay, so this is the video lecture for Math 3 Unit 2 Objective 5, and we are going to be solving and graphing equations. Sorry about that, I had been still for too long. Okay, so we need to first review our quadratic functions and how we graph, just to make sure that we can do that, because we're going to be solving and graphing our quadratic equations both, so we need to make sure we can do that. Okay, so our quadratic function, so this is our descriptive or vertex form, so that is that portion there. And we know that our start point is hk, and so we know that we get the value from h, from what is being added or subtracted to our x value, and we get the value for k from what is adding or subtracting from our y value. And our stretch, which is not the same as slope, right? Because on curves, we don't have slope, because slope you can repeat over and over again. But anytime we have a curve, we have what is called a stretch. And so that's a little bit different. So in general, our start point, which is also called the vertex, so remember this can also be called the vertex. That is our hk. And then to find two more points, we would use our stretch, a, so we would go up a over 1, right? So up a over 1, and then its reflected point would be over here. So we would still go up a, but in this case left 1. And if we wanted to know another point, we would actually have to plug values in, right? So we would have to substitute numbers into our equation, like a t-table, to get more value there, okay? All right, so the other thing that we need to take a look at is imaginary numbers. So imaginary numbers occur when we're trying to square root negative numbers. So that's when we would have an imaginary number. So an imaginary number is part of the complex number system, and it can be written as a real number that is multiplied by the imaginary unit I. Okay, so we would use I for whenever we have square roots of negatives. So it is defined by the property that when I square a number, it would generate a negative, which is unusual, right? Because normally if we take, say, 3 squared, it would turn into positive 9, and then negative 3 quantity squared would also turn into positive 9. So how do we get that negative? And that is from that complex number system. So again, the big idea right here is whenever we square root a negative number, we would get an imaginary number. So the square root of negative 1 is equal to I. Okay, so that is our new piece here as well. Okay, so let's see, how do we work with that? So if I take a look at this first one here, I have 4 is being added or subtracted to the square root of negative 12. So the first thing I'm always going to do is when I see that that negative, I'm always going to pull it out of the root, and I'm going to turn it into the letter I, right? And I'm using this little idea right here. So the square root of negative 1 is I. And so when I look at that, I'm going to rewrite that as 4 plus or minus, and this is like negative 1 times 12, right? Negative 1 times 12. And the square root of negative 1, oops, get that times 12 there. And the square root of negative 1 is I. So then this would be 4 plus or minus the square root of negative 1, so we're going to write that as an I, and then square root of 12. Okay. And so from there, I say, okay, can I simplify the square root of 12? And I can do this using factor tree, right, or the factors. So whichever way is easier for you. So this first one, I'm going to do it with factor tree method. So I'm going to just do it off to the side here. So I know 12 is 2 times 6, right? And then 6 is 2 times 3. And then I'm going to kind of scribble out that 6 because I broke it down further. So then I look for a pair. So I have a pair of 2's. So then I would have the 4 still. That doesn't go away. And I still have that plus or minus. And then this pair of 2's is going to come out. And I'm going to put it actually in front of the I, because that's similar to how we would write 2x instead of x2. We would do 2I. And then 3 did not have a pair, so it's going to stay into the radical form. And so that would be fully simplified. And I can't add that any further or simplify. That's the best I can do. All right, so let's go ahead and take a look at question number 2. So for this one right here, so I have that 6 plus or minus. And then remember that negative 20 is the same as negative 1 times 20. And then this is all divided by 2, so I'm going to go ahead and split that up and separate it, so something like that. And then I know 6 divided by 2 is the same as 3. And then that negative 1, so the square root of negative 1 is I, so I'm going to take that and I'm going to pull it out. And then divide it by 2. So I broke up the long division bar, dividing both by 2. And then I took the negative 1 out, and that turned into I. So that is how I take that negative out and make it imaginary, so I. And then for the 20, so this time I'm going to do list my factors, like just as a reminder, like another way to do that. So for factors of 20, so this is a little different. Let me go ahead and do that actually over here. So factors of 20 are 2 times 10 and 4 times 5. So I'm doing my reducing just a little bit different this time. And this is just to remind you of more than one way to do this. So for 20, so I'm going to do 4 times 5. And then I'm going to square root, so I can think of this as separate, right? So something like that. So then this would be 3 plus or minus the square root of 4, which is 2, so that'll be 2i root 5. Oops, and not all over 2, but just over 2. And then from here, 2 divided by 2 is canceling, so that would just be 1i. So that would be 3 plus or minus 1i, or just I, and then root 5. So it's kind of smushed in there. All right, so let's go ahead, and that's just going to help us with front loading for some of the problems coming up later. Okay. All right, so let's go ahead and take a look at question number 1. So for here, they want us to accurately graph f and g on the same set of axes. Okay, so they want us to do that. So we have for f of x, we have this equation right here. So I'm going to just rewrite that as y equals, right? And so f of x is the same as y. And then I want to make sure that my constant here is over with the y, because it's not in the grouping, and so I want to put it into that kind of descriptive or vertex form, right? So I'm going to add 4 to both sides, and that's just going to help me find my vertex. And so then my vertex, or my start point, so I do alphabetical order, so x before y. So I'm going to start here. And so I know then my h and my k value, so I'm going to use positive 2. So we're going to do the opposite here, right? Because that's what makes it 0. And then over here, negative 4. And again, negative 4 plus 4 is 0. So I do opposite, right? And then my stretch, which is different than my slope, is going to be 1, right? So I can always have an implied 1 there. So my stretch is 1, or 1 over 1. So then I'm going to do my start point, so over 2, down 4. And then my stretch is 1, so I'm going to go up 1 over 1, and then up 1 over 1. And I can't keep doing that, right? Like I can't keep adding values, so I have to be careful with that, right? So I can't keep adding numbers in. So I'm going to go ahead and do a t-table to find at least one more point, right? And then use symmetry for the other. So you can, do a t-table. You can substitute in values, whatever is going to be easier for you. So I'm going to go ahead and substitute in 0, because that's a nice easy one to use. So I'm going to replace x with 0, and I'm going to do it from my original equation. So I'm going to replace x with 0, so that would be 0 minus 2, and then squared minus 4. And then I'm going to simplify that. So that's going to be negative 2 squared, so that would be 4 minus 4, which is 0. Okay. So when x was 0, my y value is 0. So I also have the ordered pair 0, 0. Okay, so again, all I did was pick a number here, x. And now I'm going to use symmetry. So remember, you have like your axis of symmetry right here. So on this line right here, I was 2 away from the axis of symmetry to the left. So that means there's a corresponding point 2 values to the right. Okay. So again, one more time, I could not do stretch over and over again, right? So I can't go up 1 over 1, up 1 over 1, because that's how we do linear graphs, not curves. And so then there is my function f of x. I'll label that. And then for g of x, so g of x is equal to 0. So I'm going to use a different color here. So for g of x equaling 0, that's just saying y is equal to 0. So I go along the y-axis, so that's the vertical one, to where y is equal to 0, so that would be this one right here. And then I draw a horizontal line that passes through the y-axis at 0. And then that would be g of x. Okay, so there's f and there's g. And so then now for part A, they're asking where does f of x equal g of x? So they're going to equal wherever they intersect. And they just want the x value. So they intersect in 2 places, so here and here. And so that occurred at x equals 0, because we want the x value, and then right here, and that was at x equals 4. Okay. So they intersect at 0 and 4. All right, so let's take a look at part B. So for this one right here, we want to solve algebraically. So we already should know our answer to this, right? Because we look to see, where do these two functions equal, and they're going to equal, just like this other equation, where they intersect. So we know the answer should be 0 and 4. Okay, so but we still have to solve it algebraically. So if I look right here, I only have 1x in the whole equation, right? 1x in the whole equation. So then that means I'm going to solve by square rooting. If I had 2x, I would solve by factoring, right? So solve by square rooting, the first step is to isolate the squared term, right? So the squared term meaning this one right here. So I want to isolate that, get it by itself. So I'm going to add 4 over to the other side, a lot like what we did to graph it, right? So then I would get x minus 2 squared is equal to 4. And then once we get the squared term isolated, our next step is to square root both sides. So then that turns into absolute value. And then the square root of 4 is 2. And then from there, we have an absolute value equal to a positive number, so we're going to have 2 equations. So we have x minus 2 is equal to 2. And then we have the negative version, right? And so we've been taking that shortcut, so normally the negative would be over here, but we always divided it over, so we're just saving that step, right? So instead of dividing it over, we're just going to do it in our heads, right? So it's going to be equal to 2 and negative 2. And then now solve each equation for x. So I'm going to add 2 to both sides. And then do the same on this one as well. So add 2 to both sides. And so then x is equal to 0 and 4, which is the same thing that we got when we solved it graphically, right? Thank goodness. Okay. All right, so let's go ahead and take a look at another one of these. Okay, so same idea. So we want to solve by graphing. And so again, I suggest that you press pause, right? It's very important that you press pause while you're doing these videos to try number 2, and then hit play forward to see if you got the same answer as I did. Okay, so let's go ahead and start with the graphing piece of it. So I'm going to go ahead and rewrite this as y equals for f of x. And then I want to make sure this is in vertex or descriptive form, so I'm going to subtract 2 from both sides. And then I want to find my start and my stretch. So alphabetical order, x before y, and then we're going to do opposite on both, right? So opposite on both. So then that's going to be, instead of positive 1, we're going to use negative 1. And then instead of negative 2, we're going to use positive 2, right? So alphabetical order, x before y, and then opposite on both, because that's what will make it 0. And then for my stretch, so the stretch is a number in front, so that's an implied 1 there, so that would be 1 or 1 over 1. So then I'm going to go ahead and graph that. So negative 1 and then 2 is my start, so left 1, up 2. And then my stretch is 1, so up 1 over 1, up 1, left 1. And then I'm going to do one more point for accuracy, so I'm going to go ahead and do x equals 1, because that looks pretty easy. So I'm going to let x equal 1 to find my y. So I'm going to use the original equation here, so I'm going to replace the x with 1. and then simplify that. So that would be 2 squared, which is 4. And then plus 2 is still there, and then 4 plus 2 is 6. So my ordered pair would be 1, 6. So when x is 1, my y value is 6. And then I'm going to use symmetry to find the other point that corresponds to it. So it's 2 away from here, so it'll be 2 away up here on the same level. And there is f of x. Okay, so then now I want to graph g of x. So g of x is equal to -2. And so when y is equal to -2, so I'm going to go along the y-axis, which is my vertical one, and I'm going to go down to where y equals -2, and then I'm going to draw a horizontal line that passes through the axis y equals -2. And then that is our g of x equation. So now for part A, they're asking us for where does f of x equal g of x? So where they equal is where they intersect. But if I look, these are never going to intersect each other. So if they're never going to intersect each other, then there is no solution here, right? No solution, no place where they're going to cross. And so I would just write the words no solution, or I can use the symbol, okay? All right, so for part B, they want us to solve algebraically for f of x equaling g of x. And so this was my equation for f of x right here, so I'm going to just copy that over. And I want to know where is that equal to g of x. So equal to g of x, and g of x was -2. Okay, so again, for solving purposes, I see that I only have one x in the whole equation, right? So there's the x, so that means I want to solve by square rooting. So to solve by square rooting, I want to isolate the squared term. So I'm going to isolate this first, right? So get that by itself. And so in order to do that, I need to get the +2 to the other side. And then -2 minus 2 is -4, and then 2 minus 2 is 0. So then here, normally I would square root both sides, but when I do that, so let me show that step here. So when I square root, I get absolute value of x plus 1. Whoops, make that vertical line. And then this is a negative, right? So the square root of a negative is imaginary. So the square root of -4 would be an I, and the square root of 4 is 2, so that would be 2i. So this is no real solution here, right? So because this is not a value like square root of 4, it's a square root of -4. So this is an imaginary solution. And so graphically, it's not going to show up here, right? And so because the directions don't say to solve over the real numbers, we should keep going. And we're going to see that we're not going to get any solution like numbers like we did in the previous, which were at x equals 0 and 4. So we're going to end up with imaginary solutions. And so here to keep solving, I would solve it just like I did before. And so I would have two equations. So x plus 1 is equal to 2i. And then the negative version of that, so x plus 1, and normally there's a negative out here, but we always just divide it over, so -2i. And then just solve. So I would subtract 1. And then I cannot combine these together, and I want the integer first, so the -1 first, and then the 2i second. And then 2i is positive, so I would just put a plus there. And then on this side over here, I would do the same thing. So I'm going to subtract 1 from both sides. And then again, I want this one first, so the -1 would come first. That's a negative, so -2i. The other way I could have written that is I could just write that as x equals -1 plus or minus 2i, since they are conjugates. So, and either one would be fine. I could either leave them split like this, or I can combine them like that. All right, and then let's take a look at page 2. So for page 2, this is quadratic formula. Okay, so reviewing quadratic formula. So you will need to know this equation. You're going to be using this. So let me just kind of highlight that. So this is our equation that we'll use to solve for quadratic formula. So the steps in using quadratic is you always have to make sure your equation is equal to 0. and that it's expanded out as a trinomial. So you want to make sure it's a trinomial, meaning multiplied out, so there should be no parentheses for grouping symbols, or you won't be using quadratic formula correctly, okay? So if I look over here, so I have two things wrong. One, it's not equal to 0, and then 2, I have grouping symbols. So I need to make sure I distribute, so I would multiply that x into both sides, or into both terms. So x times 3x gives me that 3x squared, and then x times negative 11 gives me that negative 11x. And then it's still equal to negative 5. So again, I have to have it equal to 0, so that means I want to add 5 over to the other side. And then when I add 5 over, then, sorry, I don't know why this light keeps going out. Okay, so that doesn't want to turn back on. Okay, so then the other part here, so then I would add 5 over, and that's why it's equal to 0. And then when I look at this, so remember, so your A, your B, and your C. So A is the number with the x squared. So A in this problem is 3, so A would be 3. B is the number with the x, making sure you pay attention to the sign. So then your B is right here, so B would be negative 11. And then C is your constant, meaning the number that doesn't have a variable with it. So that would be the 5. So then C would equal 5. And then from there, we're using our equation. So then it's just a matter of replacing each of these letters up here with the numbers down here. So for example, there's a negative there, so meaning opposite, so opposite of the value for B, and in this case it was negative 11. So that's why there is a minus here, because from the equation, and then another one because B is negative, yeah? All right, and then plus or minus, we're just copying, and then the square root symbol, and then B squared, so B is negative 11, so that would be negative 11 quantity squared. And then I have a minus here, and then I have grouped together 4AC, so 4AC. So the 4 is part of the formula, and then A was 3, right? So looking here, and then C was 5. And then all divided by, and then 2A. So 2 is part of the formula, so 2, and then the value for A was 3. And then from there, it's just a matter of simplifying. And we did some practice on this in the other notes, right? So where we were practice simplifying these complicated equations. So the double negative turned positive. If I square negative 11, that gives me 121. And then if I multiply together the 4, the 3, and the 5, I get 60. And then 2 times 3 is 6. And then from there, I would do the subtracting portion. So 121 minus 60 is just 61. And then I would just leave my answer like that for this particular problem because 61 doesn't break down into factors that will simplify. Okay? All right, so let's go ahead and take a look at a few of these problems. So for question number 1, so because I have more than one x, I will not be solving by square rooting, right? So I have to equal it to 0. So I have more than one x, so it has to be equal to 0. So I'm going to subtract 4 from both sides. And then I can try to factor this. So if I think of factors for like 4, I get like 1 and 4, 2 and 2. And so I could try to factor and group it, but I know that that's not going to work. And so in that case, then I have to use quadratic formula. So then I'm going to look for my values for A, B, and C. So again, I know A is always the number with x squared. So that case, A is going to be equal to 1, right? So there's like an implied value. So like whenever you get like that x squared or x squared, like you might want to put a 1 in there just to kind of help you think about that, right? So it's an implied 1. And then B is the number with the x term, so that's positive 2. And then C is the one that doesn't have an x term with it, so that's called our constant. So in that case, that would be negative 4. And then now I'm going to use that formula from above. Okay, so I'm just going to say it out loud. And so then this would be x is equal to negative b, so since b is 2, I need to do the opposite of that, so that would be negative 2. And then I have to square that number, so square, so b squared. And then minus 4 times the value of a times the value of c. And then don't forget that you have that negative there. And then all over, and then 2 times the value for a, which is 1. Okay. All right, so if you think you can simplify it, go ahead and press pause, give it a try, and then check your answer against mine, okay? All right, so then this would be negative 2 plus or minus. So 2 squared is 4, 2 times 2. And then 4 times 1 times negative 4 is negative 16. But I already have that negative, so that double negative is going to turn positive. And then 2 times 1 is 2. And then 16 plus 4 is 20. And then all over 2. Okay? All right, so then now we would want to simplify this a little bit further. So because 20 I know can factor out. So when I do that, I can do a factor tree if that's easier, or if you know your factors, you can do it that way as well. So that would be 4 times 5, and then 4 is 2 times 2, but we can cross off that 4 because we just broke it down further. And then I look for my pairs, so I have a pair of 2's, and then 5 does not have a pair. So I have a pair of 2, so that goes on the outside, and then 5 without a pair. Okay. All right, and then I can go ahead and reduce this as well, right, because these are all divisible by 2. So I can take a look at just the integers though, right, and not the radical, just the integers. So those are all divisible by 2. So I can simplify that. So negative 2 divided by 2 is negative 1. And then 2 divided by 2 is 1. And then 2 divided by 2 is still 1. Okay, so then that would just be my answer, just like that. Okay, and then I don't have to have this one here, like, because that's a product, but I would have to have that one there. Okay. All right, and then let's go ahead and take a look at question number 2. So again, I have more than 1x. So whenever I have more than 1x, it has to be equal to 0, right? So in order for it to be equal to 0, I need to subtract the 9 over. But before I do that, I want to distribute this so I have something to subtract the 9 with. So I'm going to go ahead and multiply the x to both the x and the negative 1. So that would give me x squared, and then minus 1x. And then multiply the 3 to both of these terms as well. So 3 times x is 3x, and then 3 times negative 1 is negative 3. And then now I can subtract the 9 because I have something to subtract it to, right? So I have that negative 3 I can subtract it to. And at the same time, I'm going to go ahead and combine these. So I'm going to do 2 things at once. So I'm going to combine like terms as well. So this x squared is still here. And then negative 1x plus 3x is 2x. And then negative 3 and negative 9 is negative 12. Okay. So again, at this point, because I have that trinomial, I would actually try to factor it, right? So I would think of my factors for 12, like 2, 6, 3, 4. And I would see if I can't come up with something that would work. And so in this case, it doesn't, right? So if I think about that a little more than I said it, then I would just go from there. All right, so let's go ahead and find our values for A, B, and C. So I'm going to do that in a different color because it's blending into that other problem pretty well. So again, my A value would be 1, right? So there's an implied 1 there. And then B would be positive 2. And then C would be negative 12. And then I would go ahead and use that quadratic formula again. So I would have x equals, and then it's negative b, so opposite of b, so that would be negative 2, plus or minus the square root of b squared, so 2 squared. And then minus the group of 4, so 4 is in the equation, times A times C, which is negative 12. And then all over 2 times the value for A. Okay, so again, I'm looking up at the equation that's not on my screen to do that. Okay. All right, and then let's go ahead and simplify. So I still have a negative 2 here, that doesn't go away. And then 2 squared is positive 4. And then 4 times 1 times negative 12 is negative 48, so negative 48. And then all over 2. And then I have that double negative, so let's make that a positive. And then 4 plus 48 is 52. And then I would go ahead and try to simplify that as well. Okay, so let's go ahead and break that up. So that would be 2 times 26, and then 2 times 13. And as soon as I break down a number into factors, I should cross it off so I don't try to use it. So I have a pair of 2's and then a 13 that doesn't have a pair. So that pair of 2's come out and then 13 stays. And then just like the previous problem, I can divide a 2 out of each of these integers, right? Not this guy, but out of each of the integers. So when I do that, I would get -1, and then that would be 1 root 13, and then all over 1, and I don't need to have that. And in fact, I don't need that one, but I do need that one. Okay. All right, and then let's take a look at question number 3. Okay, so for question number 3, I see that I only have one x in the problem. That's this one right here. So that means I can solve by square rooting. So this one won't be quadratic formula, right? So we're going to solve by square rooting. And again, I know that because there's only one x in the problem. So I'm going to subtract 2 from both sides. And then I'm going to square root. So step 1, right, for solve by square rooting is to isolate the square term, so that's why I subtracted the 2 over. And then when I square root, I'm going to get an absolute value here. And then for 8, we're going to simplify that radical. So that would be 4 times 2, and then 2 times 2. And then I have a pair of 2's, and then this one without a 2. Okay. All right, and then 2 equations because it's an absolute value. And then the negative version of that. And again, normally like we would have that negative right here, but we divide it over every time, so I'm just saving that step. And then we're going to add 1. And then this is a single term, so that 1 can't combine here. So it just goes in front just like it always does. And then that is a positive value, so that would be 2 root 2. And then over here, so same thing, add 1 to both sides. And again, we can't add these together because the 2 root 2 is combined as one term. So the integer goes first and the irrational number last, and so that's a negative, so that would be minus 2 root 2. And then these are what we call conjugates, right? So same, one positive, one negative. So then a shortcut way to write that is 1 plus or minus, and then 2 root 2. Okay. And again, either answer is acceptable. It really doesn't matter if you rewrite it. It just is tidier. Okay. All right, so last one. So question number 4. So for this one right here, what we want to do is we want to get it equal to 0. And not solve by square rooting, and I know that because I have a lot more than one x term. So what's going to be different here, though, is the x squared's on this side. So that means I want to take these 2 terms and move it over here because I want my x squared term to be positive. So I'm going to subtract x from both sides first. Okay, I can do it in one step, but I'm going to do them in 2 separate steps. And then I'm going to subtract 14 from both sides. Okay, and then I'm going to just flip it around just so I have it in the way I'm used to seeing it. Okay, and so then again, once we get into here, we should always check to see if we can factor it to save us some, time in processing through a complicated problem. If we think about can we factor it first, which is an easier way to solve a problem, we end up actually saving a little bit of time. So if we stop and think about the problem before we dive right into it, we end up saving a lot of time. Okay, so for this one right here, so I know I can factor this, so I'm going to go ahead and list out my factors. So for 14, I can use 1 and 14 or 2 and 7. And then x squared, I can use x and x. And then one of these has to be negative because I have that negative 14, right? So I know one of them's negative. So if I set up my factors here, then on this one, I know 1 and 14, if I try to get 1 and 14, there's no way that will turn into a 5, right? So I know it's not going to be that one. So it's going to be 2 and 7. So this would be 2x, and this would be 7x, but I want it to be a negative 5x. So that means I want my 7 to be negative, right? And so 7 would be negative. And then that gives me that negative 5. So then those are my factors there, right? So x plus 2 and x minus 7. So x times x came from here, which is your x squared. Negative 7 times 2 is my negative 14, and then the outside inside is what gives me that negative 5x. Okay? All right, so then once we get it factored, we're going to solve each factor using zero product property. So I'm going to take my first factor, equal it to 0, and take my second factor and equal it to 0. And then just solve each of those. So I would subtract 2. And then I would add 7. And so my two answers are negative 2 and 7. So if you happen to press pause and then now you're checking your solutions and you forward, and your answer looks, different, so maybe you tried quadratic formula, maybe you just didn't finish simplifying. So quadratic formula absolutely will work. So if you did quadratic formula and you got these two values, then kudos to you, right? And then good job. All right, and that's it for this one.